Section 8.3, let's have some reminders first from 8.1. HO is the null, HA is the alternate, which is also H1. HA and H1 are the same thing. Okay. HA is also H1. If the claim is equal, the claim goes in HO, and HA will be not equal. If the claim is more or less or different, the claim goes in HA, HO will be equal. HO always has the equal. HA can only be less, more, or not equal. They have to have the same numbers in them. P is a proportion, mu is the mean, and standard deviation is sigma. Okay. Remember, we're using sample data. That means we only have part. We can't be 100% sure. If I survey 1,000 college students and ask them what device they use, and I find 68% use a MacBook, that doesn't mean 68% of all college students. Okay? Since we have sample data, we cannot be sure we're making a guess. When we make a guess, this could be wrong, and that leads to error. Okay, we talked about the court system in America. The null hypothesis, somebody's innocent. The alternate is they're guilty. Okay, they go to trial. The jury makes a decision. Okay, hopefully they make a right decision, but there are 2 wrong decisions. An innocent person might go to jail, and a guilty person might go free. Okay, so type 1 error is rejecting the true null hypothesis. Reject that they're innocent, but they really are innocent. Okay, so an innocent person goes to jail. That's called type 1. Type 2, fail to reject a false null. So they don't reject that they're innocent, which means you keep believing that they're innocent, but that's really false. So a guilty person goes to jail. The significance level is the error that we will allow. Okay, and we use 0.10 or 10% or less. The problems will tell you what to use. Okay, the Greek letter alpha is our significance level. The p-value is the probability that HO is true. Okay, in our homework, the null always has equal. The alternate hypothesis is what the claim is. Okay, unless the claim is equal. Okay, HO always has equal. Okay, examples. If the claim is less than 54%, we use H1. P is less than 0.54. Okay, we always change it to a decimal. If the claim is more than 54%, okay, forgot to change that. If the claim is more than 54%, we use P is greater than 0.54. Okay, HO always has the equal. Okay, when we're testing a proportion, we use the standard normal distribution and check that N times P and N times Q is greater than 5. Okay, so to find the test statistic and the p-value, we're going to use SALT. Inferential statistics, 1 sample proportion. Okay, let's go there. Okay, so how would you use SALT? Okay, we want to go to inferential statistics. We're using a 1 sample proportion. Okay, the number of successes and the number of trials. and then you do your hypothesis test. Okay, so let's say 10 out of 17 people use a MacBook, and I want to test that it's less than 20%. Okay, so I would use less than 20%. Okay, so let's say the problem said that 10 out of 17 people used a MacBook. So 10 people are the successes out of 17 are the number of trials. And if we want to test less than 20%, we put 0.20 and we use less than. Okay, this is a drop down box for that. Okay, we're testing a proportion, so we're using one sample proportion. Generate. Okay, it gives you your test statistic, which is this Z statistic. That's your test statistic. And it gives you your p-value. Okay. Remember, if the p-value is less than significance, reject. There is enough evidence. If the p-value is more, fail to reject. There's not enough evidence. And that is section 8.3.